Assalamu alaikum student. Today we discuss the topic that is the application of first law of thermodynamics. In application of first law of thermodynamics, first we discuss the isothermal process. First we define it, what is the isothermal process? Isothermal process is the thermodynamic process in which system undergoes a change but its temperature remains constant. If we discuss it example, in the example of isothermal process, we take the boiling water and melting ice. Isothermal process basically have two types. In isothermal process, we discuss the two types: isothermal expansion and isothermal compression or contraction. In isothermal process, temperature is constant, so it is similar to the Boyle's law that say that P is inversely proportional to 1 over V and temperature is constant. Here we can write PV is equal to constant. Here we use the ideal gas. This is all about the isothermal process. In isothermal process, now we discuss the isothermal expansion. For discuss this isothermal expansion, we take the container in which we fill the ideal gas. Here we take the airtight movable piston, and here we apply the pressure. In this container, the wall of the containers are insulated. This means that no heat enter or leave with the wall. And the base of the container is the conducting. Here we keep the heat reservoir from which we can take the heat or we can release the heat. In this case, temperature is constant. Temperature is constant, and in this case, if we initial case where we write the pressure is P1 and the volume of the gas is the V1. Now the gas in the container is expand isothermally when we remove the weight from piston. Here we kept some weight on the piston that apply the pressure on the gas. When we remove the weight from the piston, then pressure of the gas is decreased. Here the pressure is decreased when we remove the piston. When pressure is decreased, the volume of the gas is increased. Here we take the pressure. Here we take the pressure P1, and when the gas expands isothermally, we take the pressure P2. Initial, the volume of the ideal gas is V1. When the gas expands isothermally, we take the volume of the gas is V2. How the gas expands isothermally? When we remove the weight from the piston moves upward due to the work done by the gas. Here the gas do work done on the piston, on which the piston is moved upward. When the piston is moved upward, volume of the gas is increased and pressure of the gas is decreased. When the pressure is decreased, the gas in the container is cooled down. Due to this, the temperature is not constant. To maintain the temperature T constant, the heat Q is absorbed by the heat reservoir to maintain the temperature T is constant. In this isothermal expansion, the equation of the first law of thermodynamics is Q is equal to W. Here the Q is the heat absorbed by the system. It is the positive because it is absorbed by the system. Absorbed by the system. And work done is also positive because his work is done to move the piston upward. So it is the work done by the system. So it is also positive. So this is the equation in the case of the isothermal expansion. Now we discuss the PV graph of the isothermal expansion. We know that in isothermal process, temperature is constant. In this graph, this shows that when the pressure is decreased, volume is increased in the isothermal expansion. So in the x-axis, we take the volume, and y-axis, we take the pressure. When pressure is decreased, volume is increased, and temperature is constant. Now we discuss the work done during isothermal expansion. We can show the work done during isothermal expansion by PV graph. Here this shaded area under the curve is known as the work done of the isothermal expansion. Shaded area. This shaded area shows the work done in isothermal expansion. First we discuss the isothermal expansion, now we discuss the isothermal compression. In isothermal compression, same as we take the movable piston, that is the airtight. This is the weight that applied pressure. Let's suppose in this case the pressure is P1. In the container we take the ideal gas which have non-conducting walls and conducting base. In conducting base we take the heat reservoir in which we can take the heat and release the heat. Volume of the gas in this case is V1. Now we want to the gas compress isothermally. When we compress the gas isothermally, we increase the weight on the piston. So here we increase weight on the piston. Here we increase weight. When we increase weight, the pressure on the gas is increased. When here the pressure is P1, here the pressure is P2 is increased when we compress the gas due to the we increase the weight on the piston. The volume of the gas is decreased when we increase the weight. So now the volume of the gas become the V2. Here the volume of the gas become decreased when we increase the weight. Pressure is increased, volume is decreased. When volume is decreased and pressure is increased, the ideal gas temperature is increased. We want to maintain the temperature constant. So in this case, heat is removed from the system through the heat reservoir to maintain the temperature constant. So here maintain the temperature is constant. In this case, heat is released from the system. So here the heat we can take minus Q because it is released from the system. Here the work is done on the system, so work is negative. So here we also take the work is negative. So this is the equation in the case of the isothermal compression. Minus Q is equal to minus W. Now we discuss the graph of the PV graph of the isothermal compression. PV graph of the isothermal compression is also curve. This is the graph of the isothermal compression. In this case, temperature T is also constant quantity. In this case, the graph is upward because volume is decreased. In the case of isothermal compression, when volume is decreased, the pressure is increased. This graph is also called the isotherm graph. In the x-axis, we show the volume and y-axis, we show the pressure. In this case, volume is decreased and pressure is increased. The graph is also curve path. So, how we calculate the work done? Shaded area under the curve. This shaded area under the curve shows the work done. So, it is equal to work done during isothermal compression. Assalamu alaikum student. Today we discuss the process, adiabatic process. What is the adiabatic process? An adiabatic process is one in which the pressure, volume and temperature of the system change, but there is no exchange of heat between the system and surrounding. When no heat is changed between system and surrounding, so heat Q is equal to 0. If we discuss the example of an adiabatic process, example we take the reaction carried out in thermally isolated apparatus. According to first law of thermodynamics. Q is equal to delta U plus W. Q is equal to 0. So W is equal to minus delta U. Now we discuss the adiabatic expansion. In adiabatic expansion, we know that when expansion happen, when expansion is happen, then pressure is decrease. When pressure is decrease, so the piston is moved upward. Piston is moved upward due to the work is done by the system. When expansion happen, work done by the system. When work is done by the system, so internal energy delta U decrease. So here we write internal energy of the gas is decreased when work is done by the system. Internal energy is decreased because no heat enter or leave the system. Heat is equal to 0. So equation become W is equal to minus delta U. Work is positive because the work is done by the system, and internal energy is negative because internal energy of the system is decreased because no heat enter into the system. In this case, when compression happen, pressure increase. When pressure is increased, then here the pressure is increased, work is done on the system. Work done on the system. So when work is done on the system, then work is negative. When work is done on the system, internal energy is increased. Internal energy is increased, so it's shown by plus sign. So internal energy of the system is increased, and work done is on the system, so it's shown by the negative. Internal energy is increased because when heat energy is increased, it cannot leave the system because in adiabatic process no heat enter or leave the system. Q is equal to 0. So equation become minus W is equal to delta U. This is the equation when the process is adiabatic compression, and this is the equation when the process is adiabatic expansion. Now we discuss the condition for an adiabatic process. Which condition if has, then adiabatic process can happen. First condition is for the adiabatic process is the wall of the container must be perfectly insulated so that there cannot be any exchange of heat between the gas and the surrounding. Second condition for adiabatic process is the process of compression or expansion should be fast so that heat does not get time to exchange with the surrounding. Assalamu alaikum student. Today we discuss the topic that is the isochoric process. What is the isochoric process? The thermodynamic process in which system undergoes a change but its volume remain constant. Volume is constant. Here we take the cylinder which has the fixed piston, non-conducting wall and heat reservoir. Here we take the cylinder which constant of ideal gas which have the fixed piston, non-conducting wall and conducting base. In the base we take the heat reservoir in which we can heat enter or leave the system. When heat enter into the system, then the internal energy is increased. When internal energy is increased, so the pressure is increased and temperature will also increase of the gas. So here we write when heat supply, then pressure increase from P1 to P2, temperature increase from T1 to T2, and volume is constant. When volume is constant, then no work is done because neither expansion nor compression. Work is done when the gas is expanded or compressed. Here the fixed piston no, so the gas neither expand nor compress, so work done is zero. So first law of thermodynamics, that is equal to Q is equal to delta U plus W. Work done is zero, so heat supply is equal to the internal energy of the system. Now we discuss the PV graph of the isochoric process. In x-axis we take the volume and the y-axis we take the pressure. Volume is constant, so here the graph is the straight line. This is the graph of the isochoric process with the volume is constant. In this case, work done is equal to 0. For an isochoric process, area under the curve is 0, so work done is equal to 0. Assalamu alaikum student. Today we discuss the topic, that is the isobaric process. First we discuss the definition. What is the isobaric process? An isobaric process is defined as one in which the pressure of the system remain constant during its change from the initial to final state. In this case, pressure is constant. To understand the isobaric process, here we take the container which consists of an ideal gas which have the non-conducting walls and consists of conducting base that consist of heat laser wire. The pressure of the gas is constant, so here the piston can move. When we give the heat into the system, heat observed into the gas, then internal energy is increased. When internal energy is increased, that to work, then they do work. Due to this heat observation, the gas expand. When the gas expand, they apply the pressure on the piston. Due to this, the piston move upward. It means we do work on the piston. Piston move the distance delta x. Let's suppose is this the initial position of the piston, then the piston is moved upward. We do work done W on it. Initial pressure of the gas is V1 and final pressure of and volume of the gas is V2. So here, when we supply the heat into the system, the total heat convert into the work done, and we know that the work done is equal to the F into displacement. So we know that the formula of the pressure is force per unit area. Here we apply the force on the piston, that area is A. So pressure is equal to force by area. Here we calculate the value of the F, that is equal to F is equal to PA. So here put PA T. We know that the area into distance is equal to volume. So it is equal to change in volume. We know that here in this case volume is changed from initial state to final state. It also write as V2 minus V1. Now put it in the first law of thermodynamics. First law, that is the Q is equal to del U plus W. So here the equation become Q is equal to del U plus W is equal to P delta V. We can also write as Q is equal to delta U plus P V2 minus V1. Now we discuss the PV graph of isobaric process. For this we take the volume in x-axis and pressure in p-axis. In isobaric process, the pressure is constant and volume is changed from V1 to V2. So here the pressure is constant and volume is changed from V1 to V2. So when the pressure is constant, we get the straight line graph. This graph shows the isobaric process. This graph is also called isobar. We know that the area under the curve is equal to the work done. So we know that in the case of isobaric process, work done is equal to pressure into change in volume. So here we write area under the curve is equal to work done W, that is equal to pressure and change into volume.